Welcome. This week we're going to be going over the Way ANOVA. So I thought we would try using Edpuzzle as a way to do this kind of distance learning for us now. Rather than doing a live session on Wednesday night for those 4 hours, I thought it would be better to kind of have this pre-recorded one that you could watch on your own time, because I know all of our lives are kind of turned upside down right now. And I thought this would be the best way to make sure that everyone in class can get the same exact material and all participate in the same way. So at the end of this thing, you'll be able to give me a bunch of feedback on whether this worked for you or didn't work. If you're having lots and lots of issues and you're very confused, obviously reach out to me and we can either, FaceTime, Skype, Zoom, something to, see each other one-on-one to go over things. But I'm hoping that you'll find this video very informative and that you'll be able to, pause it and rewatch things as you go. And I'm also giving you a chance to ask me questions throughout. So with that, let's get started. I thought we should just kind of go over what we've learned already. It's been a little while. I'm not going to actually do any of the actual SPSS work for these things, but I am just going to include some of them there just so you remember what we've done. So we know how to do descriptive statistics. We go up to analyze descriptives and explore, and then we put in all the different things that we want. We've learned how to create scatter plots by going to the legacy dialogues and getting the scatter/dot plot. We've learned how to compute new values if we need to in SPSS. We've learned how to do correlation. We've learned how to do linear regression. What we started to do in week 3, so before the test, was to talk about inferential statistics, right? So the whole purpose of inferential statistics is to test hypotheses about population parameters. So basically, we're using samples to try to make a guess about the population. To do that, we do something called hypothesis testing. There's 4 different steps that we follow for an hypothesis test. So we start off by stating the hypothesis, and there's always a null hypothesis and an alternative hypothesis. Once we have the hypothesis stated, then we always like to set the criterion for how we're going to either reject that hypothesis or fail to reject that hypothesis. And it all comes from whether things are unusual or not. So our typical value for this is 5%, because anything that happens less than 5% of the time is generally considered unusual. But we could also use 10% or 1%, it doesn't have to be 5%. And this is referred to as the level of significance or the alpha level. Once we've done that, then we actually go about computing the test statistics, which is basically using SPSS to find either a z-score, a t-score, an f-score, some sort of score. And we just let SPSS do that for us. And while SPSS is doing that, it also calculates something called the p-value or the probability value. And there's 3 different types of hypothesis tests that would give you 3 different types of p-values. The main one that we use is called a two-tailed test, and that's when our alternative hypothesis is just saying that there is not equal. So basically, the things that we're comparing are not equal. The other 2 would be a left-tailed test, which is when you're saying one's less than the other, or a right-tailed, which is when one's greater than another. And we typically don't use either the left or the right without some sort of research-based backing to decide which way we should do. So typically stick with the two-tail. Once we get that p-value, we like to compare that to the alpha level, okay? So if the p-value is smaller than the alpha level, then we're going to reject the null hypothesis. And that's because small p-values, nobody wants them, so we're going to reject. If the p-value is larger than the alpha level, then we're going to fail to reject, which basically means that we don't have enough evidence to say that the null hypothesis is incorrect. Our first real exploration into doing hypothesis testing was through t-testing. So a t-test is used to compare the means for one variable for 2 different groups, okay? So we have one dependent variable and then one independent variable with 2 levels. Can't be more than 2 levels. And there's 3 different types: the one sample, the independent samples, and the dependent samples. And the next couple slides in the PowerPoint are just going over what the difference is between each one of these three and how to run them in SPSS. And I'm not going to go over that in this particular video, but I'm leaving them in the PowerPoint so that you could refresh your memory if you need to. We are going to come back and do more work with the independent samples t-test on the Saturday class when we compare this test to the one we're learning today, the Anova. Okay, so all of these are just the different types. Which brings us to the one-way ANOVA that we're learning this week. All right, so the one-way ANOVA, basic definitions and types. So ANOVA is short for analysis of variance, which is basically what all of these hypothesis testing are doing. We're basically testing to see whether or not there's any variance or difference between groups. So an analysis of variance is us doing an analysis of whether there's differences. A one-way ANOVA is used to compare the means for one variable for two or more different groups. Okay, so the t-test was two groups, exactly two, and a one-way ANOVA can handle two, so you could do an ANOVA instead of a t-test. Or if you have more than two groups, then you have to use an ANOVA and not a t-test. There are two primary one-way ANOVAs. One is called the between subjects ANOVA, and the other is called a within subjects, which basically connects back to the independent samples t-test versus the dependent samples t-test. So between subjects, comparing the means between two or more different groups and deciding whether they're significantly different based on that dependent variable. So we need an independent variable that has two or more separate groups. Okay, the groups have to be separate from each other. And then some dependent variable at the interval or ratio level. So our example here is we wish to see whether there's a difference between three different learning strategies, either A, B, or C, on some instrument. For the within subjects, this time we're going to be comparing the means between two or more related groups. So typically this is when you do something over time. If you were to have multiple checkpoints over time, then we would want to use this within subjects. Okay, so we have independent variable for two or more related groups. Dependent is still at the interval or ratio. An example of this would be if you want to see whether there are changes over time, either before, during, or after, within a group of students. Okay, so because there's three different measurements over time, we'd have to use the ANOVA versus if there's just a before, or after, or pre or post, we could use a t-test. So there's these things called the Tukey Post-Hoc Tests that are associated with the ANOVA. So basically, if a one-way ANOVA comes back as having significance, meaning that there is a significant difference between the groups, we need to figure out exactly how those groups differ. Okay, because remember that there's more than two. There's, 2, 3, 4, 5, etc. different groups. So we need to know like where those differences actually happening. So one way would be to test all possible pairs of groups using something called a pairwise comparison. So we could actually do that. We could just take each individual group and do a t-test and compare every possible grouping. But that seems silly to have us manually do that when we can ask SPSS to do it for us in this Tukey's post-hoc procedure. And what the post-hoc would do for these, let's just say the three examples, the three levels in the example here, A, B, and C, is it would compare A versus B, A versus C, and B versus C. So it does all three of those for us automatically, rather than us needing to do three independent samples t-tests. Now, if there were four groups, it would get a lot more complicated. You would have to do A versus B, C, and D, and then you'd have to do B versus C and D, and then C versus D. And I'm pretty sure that was 6 different levels. And if you had 5 different levels, then things just keep getting more and more. So we definitely wouldn't want to have to manually calculate all of those t-tests. We would just let SPSS do it for us in this thing called the Tukey post-hoc. All right, when we were learning about t-tests, we also learned about this concept of the effect size. So basically, hypothesis testing is indicating whether or not there's significance between groups or not. So it's a yes or a no question. And what effect size is doing is giving us an indication of the magnitude or to what degree is this difference happening. Okay, so the ANOVA uses the partial eta squared, And Cohen gave us these estimates for the effect size, and they're different than they were for the t-test because the t-test used a delta level, and this is a partial eta squared, so they're different for different tests. So you'd have to look up the effect size for each individual test. So for these ones, 0.01 small, 0.06 medium, 0.14 would be large. So the way that we calculate this is with this formula here, this sum of squares between groups divided by the sum of squares total. And SPSS is going to find those sum values for us, but we still need to manually calculate this eta squared value, which we'll do in the example. To run a one-way ANOVA in SPSS, we just follow these pretty simple steps here. We go to Analyze, Compare Means, and this time we go all the way to the one-way ANOVA. We put our dependent variable in the dependent list. We put our independent in the factor box. And then we do some other things in here, which I'm going to show you with the examples. Okay, but I just wanted this nice clean slide here that goes over how to do it for your reference. But we'll click Options. We'll ask it to give us descriptives. We'll also ask it to give us this homogeneity of variances test. And that's to help us with part of the assumptions that we need to check for the one-way ANOVA. And then we click Continue, and then it gives us this option for Post-Hoc. And when you click on this, you'll see that there's like a lot. So we're just going to click on the one that says Tukey, not Tukey B, just Tukey. And again, I'm going to do this with you in like 3 slides. For the one-way within subjects ANOVA, I'm just going to suggest that you consult either the Yaki book or the Hinkle book, because we're not really focusing on this style of ANOVA in this class anyway. And I just think that it's silly to go over this really complicated way of doing this ANOVA if we're most likely not going to do it. So if this came about that you were doing your dissertation and you actually did have this one way within subjects, you would just refer back to the books to learn how to do it. So I'm not going to go over it with you in this video or in this PowerPoint because our main focus is going to be on the between subjects. Steps for the data analysis of a one-way ANOVA. These steps are the same exact steps that we've been following all along. They are identical to the t-test one. It's just that now we're going to be using a one-way ANOVA, which will change some things, right? So our assumptions will change a little bit, potentially. The computing the test statistic, obviously we're going to use an ANOVA instead of a t-test. And then how we report the results will be slightly different as well, because we have more options than just comparing A versus B. We have to compare A versus B, A versus C, and B versus C. So we have more things going on, so it makes it a little bit more complicated. The example that we're going to be working with is we wish to see whether there is a difference between 3 different learning strategies, either A, B, or C, on word recall. So our specific example here is that there's 30 students were randomly assigned to receive one of 3 different strategies. We put 10 people per group. After learning the strategy, each student was shown a list of 15 words to remember. And after giving them a brief amount of time to learn those words, and then taking the words away from them and waiting a little while, we were then asking them to write down as many words as they could. And we just recorded the number of words that they could correctly recall. And we've captured this data inside this session 5 example data. So I'm going to jump over to SPSS real quick. Here is the session 5 example data set. We have, let's see, I lost my mouse. There we go. We have this strategy and we have word count. If we go to the variable view, we can see here that we have the name. I've given them a label. If I were to click on this, we can see how they were coded in SPSS. So strategy was coded as 1, strategy A coded as 1, B 2, C 3. We can see they're at the nominal level, and word count is at the scale level, which is really the interval level for us. Okay, so that's the data set that we're going to be working out of for this particular example. And we'll just work through all of the, I think it was 11 different steps. Yes, 11 different steps together right now. Step 1, we have our data cleansing. So this data has been cleansed. There were no missing values or obvious errors in the data entry. And again, you'll learn about this more in other classes, how to actually go about doing this. But for now, that's given. Our research question: is there a statistically significant difference between the word count for different learning strategies? Strategies A, B, and C. Step 2 is stating the research question, or questions, in this case just a question. Is there a statistically significant difference between the word count for different learning strategies? Either A, B, or C. Step 3 is stating the independent variable. So in this case, the independent variable is the learning strategies with 3 levels, A, B, or C, and they're at the nominal level. Step 4, dependent variable. The dependent variable is represented by word count and is on the interval level. Step 5, we take the null and alternative hypothesis. So we basically take our research question and take it from a question to make it a statement of fact. For the null, we say that there's no significance, and for the alternative, we'll say that there will be one. So always just take the research question and reframe it as a statement instead of a question for each one of these. And I'll remind you that we're going to stick with the non-directional hypothesis because we can't use directional unless we have a research-based reason to pick a direction. Alpha level, this is pretty much the same for us. The statistic will be tested at the alpha level of 0.05. Step 7, we state which type of statistical analysis we're going to be doing. So we're going to do a one-way ANOVA, will be used to analyze differences between strategies A, B, and C with respect to the dependent variable, which is word count. There are 3 assumptions, which are the same 3 assumptions for the t-test. We have independence, normality, and homogeneity. So independence, we just basically make a statement saying that members of each individual strategy group were never a member of the other strategy group, so we know that the samples are independent of each other. For normality, we need to check the skewness and kurtosis, and then we basically fill in the blank here. So let's actually go about and get that in SPSS. So here is SPSS. I've lost my mouse. There it is. And we're going to go up to Analyze, Descriptive, and Explore. Okay, I'm going to move the word count in the dependent list and strategy into the factor list. And again, I like to always just click on these. I can actually make this a little bit bigger on your screen. I always like to click on these just to see what's going on. So for this one, I'm cool with box plots being together. I'd like a histogram as well. Don't need that, and I can ignore this part down here, and we can ignore that part. So I will hit OK and zoom myself out. And here I have all of those. So I have the skewness and kurtosis is between -1 and 1 for all of them, so they're good. I can look at their graphs, can look at their stem and leaves if I need to. I found this box plot to be the most interesting part about the descriptives because you can look and see that C is much lower looking than either A or B. So I would expect that maybe there's going to be significant difference between A, B as compared to C, but maybe not between A and B themselves, okay? Next, we're going to do the test for the homogeneity of variances in SPSS. So it does this for us when we're doing the ANOVA. So just like with the t-test, how it would kind of do it automatically, this one doesn't do it automatically. We have to check a box, but it does give us this output that you can see right on the screen. This is for this example. And the way that we would write this is we would say F parentheses, and then we include these degrees freedom here. So we would do 2,27, close parentheses, equals 0.021. Okay, all of that would be for this F value that we have going on there. Didn't mean to switch sides there. And then we have the actual p-value here, so the significance is 0.98. And it's really important here that it's not significant, and we don't want it to be significant. We can't run the test if the variances are not equal. And if there were a significant difference between the variances, that would say that they're not equal, and then we couldn't use this test. Next is we actually compute the test statistic using SPSS. So let's actually go do that. So I'm going to jump back over to SPSS. I'm going to find my mouse again because I lost it. This time I will go to Analyze, and I would like to compare means. And I believe I can zoom in on this again. Here you go, compare means. And we were using these t-test ones last time. This time I'm going to go to the one-way ANOVA. Okay, let me unzoom and then rezoom. I'm going to put the word count in the dependent list, strategy in the factor. Next, I'm going to check all of these boxes here. So I'm going to do contrast, and none of that's important, so I can ignore it. Post-hoc is important. I want to check this Tukey one, not the B, just this Tukey one. And click continue. Then I'm going to go to options, and I want to get the descriptive and the homogeneity of variances test here as well. So the only reason I'm getting descriptives is it just gives me a nice, prettier box for the descriptive statistics rather than the ones that we've already run. And then this is important to test the assumption for the homogeneity of variances. And now we'll just click OK, and it will run that for us. Let's zoom in a little bit here. We can look at, this is the nice summary of the descriptives. So it just gives me the means and standard deviations right here. So it's a little easier to read when I go to write that summary later on. Here's this test for the homogeneity of variances, and all we really care about is this top line based on mean. And that's the same thing that we had in the slide on the other page. I'm going to jump back to it so you can see. It had 0.021, 2, 27, and 0.98, and that is what this top line is. We can ignore the other things. We don't care about them. Next, we have the actual ANOVA itself. Okay, and things that are important for us here. Here's the sum of squares for the finding the effect size. So this is the sum of squares for the between group. This is the sum of squares for the total. We have the degrees freedom that we are going to use when we're writing this formally. We use the 2, 27. We don't ever write the 29. This is the actual F score, so 38. And this is our p-value. Now, below that, we have the post-hocs. And there's two different ways that you can look at the post-hocs. There's this kind of multiple comparison one here, or this kind of subset down here. And it doesn't matter which one we look at, honestly. So I'll start with the multiple comparisons, and then we'll jump down to the second one. So if I look here, these little asterisks are telling me where significance falls. So A as compared to B, no significance. You can see the p-value is 0.138. A compared to C, the p-value is less than 0.001, and it has a little asterisk. So we know that A and C are statistically significantly different. When I jump down to B, you can see B and A, we already know that they're not significant because we've already checked it up here. But B to C is also significant. And then this one is kind of irrelevant now because we already know that C is statistically significantly different from A and B. When we jump down here to this chart, let me zoom that in a little different. There we go. When we look at this chart, we can see that C is in a column by itself, which means that it's significantly different from the other column, A and B. And since A and B are in the same column, that means that they are not statistically significantly different from each other. So basically, it tells us the same thing as this chart in kind of a different way. I personally prefer this chart because to me it just makes more sense to look at it this way. But this one works just as well, where you have C and then A and B are similar, and then if they're in different columns, they're different from each other. So that's the SPSS output for us. And all we have to do now is just actually write this all up. All right, so step 10, we have to report the results that we got from SPSS, okay? And you can see that this is much more involved than it was with the t-test. There's a lot more going on and a lot more stuff that we have to do. So this first bullet point is basically just saying, did the ANOVA find significance, yes or no? And then also, what is the effect size? What is all of, the F score and the p-value? The next bullet points down below, we have to do something different. If there's significance, we need to use the Tukey post-hocs to then say what the actual specific differences were. If there wasn't significance in the ANOVA, then there's no reason to do a post-hoc. And so we just basically say that there was no statistically significant difference with respect to these groups. I'm going to go line by line kind of through this with you, how I wrote it, and I will put what I'm saying out loud up on the screen kind of at the end after I finish saying it, so that you have a chance to see it written out. So I would start off based on this ANOVA. I lost my mouse, but based on this ANOVA up here where it has a significance level of 0.000 and all of this stuff, I would say there was a significant difference in word count between learning strategies. F parentheses 2 comma 27 equals 38.07, P less than 0.001. For this partial eta squared value, what we would do is, I need my mouse, there we go, is I would, in my calculator, do 165.267 divided by 223.867. So basically, I'm taking the sum of squares of the between group, dividing by the sum of squares of the total, and I would get 0.74. If we were to jump all the way back to the slide that had the effect sizes on it, so we got an effect size of 0.74. Now that's very large. I just want to go over again, what is that, partial eta squared value and the effect size actually telling us? So basically, this value of 0.74 would correspond to a very large effect in practice, so in the real world, and it indicates that the learning strategies accounted for 74% of the variance that we saw in word recall. So that's something that you would 100% be writing fully out in great detail in the dissertation. All right, continuing on, we have this first sentence pretty much done now. And since we did find significance, we are going to use this kind of second prompt down here. So I would say, Tukey post hoc comparisons on the levels of the independent variable indicate that strategy A, with a mean of 8.9 and a standard deviation of 1.52, with a p-value less than 0.001, and strategy B, with a mean of 10.2, a standard deviation of 1.4, and a p-value of 0.001, had significantly higher word count than strategy C, with a mean of 4.7 and a standard deviation of 1.49. There were no statistically significant differences with respect to word count between strategy A and B. Okay, so I did A versus C and B versus C all at once. In this case, I could do that. It worked kind of nicely for me. And then I also summed it up at the end there with saying that A and B had no difference between each other. And all of that came straight from just looking right here that A and C were different, B and C were different, and A and B were not different. And I was just using the means and standard deviations from right here to be able to write that super quick and simple. Step 11, we have to interpret the results. So we would say the null hypothesis that there will be no statistically significant difference between the word count for different learning strategies, A, B, or C, was rejected. So for assignment 4, you're going to be asked to perform a one-way ANOVA. And the scenario that we have going on here is we're interested in whether there is a difference in the science process skills, SPS for short, for 5th grade students with different teacher groups, either A, B, C, or D. So basically we have 4 different groups of teachers here, and we want to see whether or not there's difference between the science process skills within these groups. So your actual assignment, perform a one-way ANOVA to address this scenario. You have the data set, ANOVA homework data, and I also have provided you with the blank template for you to actually fill in your answer. Now, I do want to make a note here that this data is a little bit more involved because there's 4 groups now, so A, B, C, and D. So when you're doing step 10, it's going to be a little bit more of an involved write-up because there could be a lot more comparisons that you have to make. So it's okay if you don't get it 100% perfect. I am guessing that we're probably going to start our Saturday class with me going over this, and that's going to be okay. So don't stress about it. Let me know if you have any questions, comments, or feedback on how this went for you and whether you liked kind of the way that I presented the material and went over the examples with you, and also how Edpuzzle worked for you. And I hope you're all staying safe and staying sane while we are experiencing this fun-filled social distancing and work from home experiment.